Welcome to this chapter titled Installation of Lightning Protection Systems. The installation of lightning protection systems must follow a precise method to be effective. This chapter explains how to correctly install the key elements: lightning rods, surge arresters, and grounding systems. The goal is to ensure reliable protection for buildings, equipment, and people. Ready? Let's go for the best installation. The fundamental principles of lightning protection are simple. Capture the lightning and safely discharge it into the ground without endangering people or equipment. This system relies on three essential components: the lightning rod, the down conductor, and the ground connection. Installation must comply with current standards such as NFC 17102 or IEC 62305 to ensure effective protection. Lightning protection is essential for several reasons. It ensures building safety by protecting against direct strikes. It protects people by reducing the risk of electrocution. It also helps preserve equipment by limiting overvoltages in electrical installations. A lightning protection system has three parts: lightning rod captures the lightning strike, down conductor carries the electricity to the ground, ground connection safely disperses the electricity into the soil. In short, the rod captures the lightning, the conductor guides it down, and the grounding eliminates it. To install a lightning rod, consider the following. Placement: install the lightning rod at the highest point of the building, at least 2 meters above surrounding structures. Protected zone: it creates a protection cone underneath. The higher it is, the larger the protected area. Down conductors: connect the rod to the ground using wires fixed along the walls. The shape and size of the protected area depend on height and chosen protection level. The cone: the rod protects a cone-shaped area beneath it. Height: the taller it is, the larger the protected zone. Protection levels: there are 4 levels. Level 1, strong protection. Level 4, basic protection. Radius: the cone is wider with lower protection levels. To install a lightning rod, first assess the risk based on the building and location. Then mount the rod at the highest point, at least 2 meters above nearby structures. Install a grounding system with resistance under 10 ohms. Use copper or aluminum conductors to direct the current safely to the ground. The surge arrestor protects electrical equipment from overvoltages caused by lightning. It is installed at the top of the electrical system, often in the distribution board, and limits the voltage that reaches sensitive devices. To install a surge arrestor, first, check whether the site is in a high-risk zone according to NFC 15-100. Then select a Type 1, 2, or 3 surge arrestor based on the required protection level. Install it near the main circuit breaker and connect it to the phases, neutral and ground. Finally, test its function and document the installation. Grounding allows the safe dissipation of leakage currents or overvoltages. It reduces the risk of electrocution and material damage. It is also essential for proper operation of protective devices like residual current devices, RCDs. Soil resistivity varies by terrain type. Marshy soil, 330 ohms, plastic clay, 50 ohms, loam, 10-1500 ohms, compact limestone, 1000-5000 ohms, granite and sandstone, 1500-1000 ohms. The lower the resistivity, the better the conductivity. Moist, clay-rich soils are better than dry, rocky soils. Foundation grounding. A bare copper conductor is placed at the bottom of the foundation before concrete is poured. Ideal for new constructions and effective in moist, conductive soils. Rod grounding. Metal rods are driven into a trench. Suitable for existing buildings. Requires a trench about 1 meter deep. Verification is done using a ground resistance meter, tellurometer. A disconnect bar allows for continuity checks and resistance measurements without dismantling the installation. 5. O. Ideal resistance, recommended maximum for good grounding. 100 Ur, general limit according to standards. 30 Ur, target value for 30 mm RCDs to ensure optimal protection. For trench grounding, Dig a trench 1 meter deep and 10 meters long. Lay a 25 mm copper cable. Insert a ground rod every 2 meters and connect them to the panel. Check the connection. Then measure a resistance of 100 ohms or 30 ohms for 30-meter RCDs with a tellurimeter before backfilling. The ground cable from the trench is connected to a disconnect bar, usually made of brass. This bar connects the ground system to the electrical panel and allows easy checks and measurements. Installing lightning protection is important to safeguard people, buildings, and equipment. It requires proper installation of lightning rods, down conductors, and an effective ground connection. This chapter provides a simple method to safely carry out the installation. Thank you for your attention.